Next is Katherine. So if I may ask you to share your screen whenever you are ready, and also unmute yourself, that would be great.
Great, thanks. Hi, I'm Katherine Valde. You'd think I'd get better at sharing my screen, but I haven't. All right. Here we go. All right, so that was really wonderful, Anya, and it helps me a lot. So a lot of the things that Anya just talked about the sort of the not theory neutralness of cancer research are going to be things that I reiterate, although in a less sophisticated way, because ultimately my goal is to talk about how we can think about using metaphysics to institutionalize pluralism. What I mean by this is making arguments about metaphysics and about the underdetermination and pessimistic meta-inductions to try to convince us to take up a pluralistic approach to methodologies in research. Okay, but first, I will. Okay, so I want to start with just sort of giving an overview of my plan for today. So I'm going to start with this idea that there's a move from metaphysics to methods. I start here because often metaphysics seems, I guess, fairly esoteric or disconnected from the practice of science. But the more I've listened to scientists describe the kinds of inferences they're making and importantly, the kinds of complaints they have about the demands from journals or granting institutions, I see that there is this sort of inference from metaphysics to the kinds of methodologies that would be most effective for a sort of a given research project. So I'm going to start by sort of motivating this influence. Then I'm going to move on to a case study, which is cancer research. I'll use cancer research sort of throughout this as the motivating case to show this inference. And I have to be honest, part of why I use this is because we find it very motivating. We are extremely motivated in the cases of cancer research to find solutions, to find cures, to figure things out, and that really works in favor of my argument. So cards on the table, that's part of my motivation. But I'm specifically going to look at different ways of approaching cancer research and how they're in some ways can be understood as based on metaphysical inferences. I'm not interested in which way of approaching cancer research is best, or I'm not interested in that kind of inference, but what I'm interested in is just seeing this connection that's made from ideas about how the world works, what there is, how the body works, what kinds of things there are in the world, lead us to understand what kinds of methods would be best suited to approaching the problem. And I'm going to use these examples to illustrate different attitudes that researchers can take, either just unreflectively trusting the sort of baseline assumptions they have about what there is and what it's like. You can have a passionate affirmation. You can be really, really excited about your chosen metaphysics, use it to develop your theory and apply it. But ultimately, the question I'm really interested in is, are these the right attitudes, or what kinds of attitudes should we take? The most obvious answer might be, no, not these. We should be agnostic about metaphysics. We don't know. We don't know what kinds of, ultimately, the world is like in that sort of deep metaphysical way, so we should be agnostic. And that is sort of what I thought when I started doing this project. But ultimately, I think that individual researchers might be motivated knowingly or unknowingly by these sort of metaphysical commitments, and ultimately it doesn't really matter to the system of science as a whole if some individual practitioners make these kinds of metaphysical inferences. What we're really interested in is a system that can generate a diverse set of research practices. And so what I want us to think about is how at a higher level, not at the level of the individual practitioner, but at the level of journal editors, company executives, people who are funding grants, we can use these kinds of inferences to guarantee that a diverse set of methods are utilized in the research as a whole. Okay, so as I said, my examples are going to be from cancer research, and here I just want to start with this move from metaphysics to methods. In a lot of science, including cancer research, metaphysical presuppositions can get linked to theories through a sort of ontology or an understanding of what there is. Often I get some pushback at this part of this, so I like to take us as far away from our own metaphysical intuitions as I possibly can in order to motivate this idea. And so I start with Hippocrates, who told us that that the body was made of 4 cardinal fluids, right? Dictating a sort of ontology for us, what there is, what it's like, right? There are a bunch of properties that the different 4 cardinal fluids had. This ontology was used by Claudius Galen to develop a theory of carcinogenesis, that cancer was trapped black bile. It was caused by an overgrowth of black bile. And importantly, this dictated methods for cancer researchers, for people who are trying to study, understand, and prevent cancer, most particularly that we shouldn't operate on cancer. We should not perform surgery. Why? Well, because of our underlying idea about what there is, because there's black bile and it's trapped, it's a systemic problem. So cutting out a tumor isn't actually treating the underlying condition, which is systemic. So if you cut out the tumor, it's just going to regrow, or it's going to be somewhere else because the circulating overgrowth of black bile is present everywhere. Of course, eventually, we started doing dissections. We discovered that the body wasn't made of 4 cardinal fluids, and this caused people to think that this wasn't what cancer was in fact. And it opened up the idea that we could use surgery to treat cancer, that we could operate on tumors and remove them. And in fact, removing some tumors is still an effective way to treat some cancers. The details aren't, I just want to motivate this idea that how we think about what there is can change how we think about what kinds of methods would be best, that there's this sort of move that we're making. Okay. So I want to motivate the idea that this is still a sort of part of our world. This didn't just happen a long time ago. We're still doing this, we're making this kind of inference today. A very quick sort of overview in a non-sophisticated way of how we think about some kinds of cancer research or theories of carcinogenesis. So prior to the 1970s, we were really interested in treating cancer and how to testing treatments and then using them. But then there was a call to better understand cancer itself as a way to understand how to treat it better. So I like this quote. It was as if the whole discipline of oncology had both prevention and cure had bumped up against a fundamental limitation of knowledge. We were trying to combat cancer without understanding the cancer cell, which was like launching rockets without understanding the internal combustion engine. So what the call is here is for, we need to know more than just that a patient starts in a disease state or ends in a healthy state, or starts in a healthy state and ends in a disease state. We need to know something about an internal mechanism. What is the cause? What are the parts, and how are they working together to cause either a healthy state or a disease state? And I think we can see this, understand this as growing out of a sort of mechanistic metaphysical framework. Okay, so a lot of philosophers of science or philosophers of biology have seen the mechanistic metaphor as an explanatory aid, or but the demand that we look for and discover mechanisms, I think, illustrates that mechanistic thinking is also a metaphysical framework, at least in some sense. It's a way of understanding the natural world and generating future expectations. So both mechanistic explanations and mechanistic philosophy more broadly share the assumption, share assumptions, basically what the world is in ontology. So the same way that you could think of it as made of 4 cardinal fluids, you can think of the ontology here as one of entities. So there are particular entities and their activities, and you look to finitely characterize the properties of entities that allow them to execute their activities. So you look at there are entities, and then you look at their properties to understand what's happening. You can see this, I think, illustrated in somatic mutation theory, which sort of grew out of this call. So cancer is caused by somatic mutations, changes to DNA cells. The default state of cells, so we have assumptions about what is the default, about how things are to start with. Cells are stable, they don't change, and mutations will act independently of context. The correct mutations are going to cause cancer. Obviously, things have been updated in certain ways. I think what's important for me is just how we can see this link between what we're thinking the world is like and how the theory is being understood. That is, somatic mutation theory characterizes carcinogenesis in terms of properties of entities, mutations to DNA, that give rise to an action, cancer, or deranged cell growth, something along those lines. All right. Oops. So the key idea here for me is that there's a connection between how we ought to study or approach understanding cancer. This would lead to approaches that look to understand the particular mutations, right? We should list them, catalog them. We have particular methods that are going to grow out of an understanding of the world that's based in this way. I'm going to contrast this with another way of approaching it, not to say one is better than the other or that we should use one or the other, but to highlight the kind of inference that's being made. So that is tissue organizational field theory, which is another theory which is going to tell us that cancer occurs when constraints which ordinarily restrict cell growth are removed. So the default state of cells is to grow and change, and when you remove the things that normally restrict them, they can grow out of control, which is what happens in cancer. Mutations are healed in healthy context and induced in a deranged context. So you see a different idea of what the base state is, which makes us think about what cancer is and what's causing it in a different way. Importantly, you can see this as growing out of this. In this case, this was born out of a new ontology for cells. The theory itself comes from an idea that we are thinking about what cells are and how they work incorrectly in a lot of the other research. So the idea was born of the idea that proliferation with variation in motility is the default state of cells. So it's not merely an account of carcinogenesis or how cancer starts, but it's also it's a set of ontological and metaphysical presuppositions. The scientific challenges, so there are parts of challenges that may be you wouldn't expect these observations under a somatic mutation theory. Anya was talking about some of these observations, right? How we can heal cancer cells in healthy contexts, or mutations that occur after cancer has already started. These kinds of observations might motivate a change to this kind of theory, but what's important for me is that it's growing out of this idea about what cells are and how they behave. It can be seen as growing more generally out of a different framework in general, and it can be actually seen to be guided by this idea. So there are arguments in the literature that argue for this idea that we need to understand cancer more as a process rather than as a mechanism. It looks to understand how systems are stabilized rather than why they change. So how in general are we maintaining healthy cells rather than studying what properties of the cells lead them to grow in a deranged way. So this kind of perspective would lead us to different kinds of research projects. Scientists from this kind of perspective ought to focus on studying cancer in a in a dynamic coupling between proliferation and differentiation that occurs in healthy tissue. So you should study the dynamic activities between tissues if you're thinking about cancer in this sort of way. The default state of an individual cell is going to be to grow, but cellular growth can be constrained somehow, and so you need to understand those things. Okay, so I'll zoom back out. So we have different theories of carcinogenesis, right? On the one hand, we have a somatic mutation theory. On the other hand, we have a tissue organizational field theory. What I'm really interested in is that we can see these as dependent on or inferred from different metaphysical frameworks, a mechanistic framework on the one hand and a process framework on the other hand. Okay. And we can see different attitudes sort of present in these different research frameworks. On the one hand, you can see an attitude of sort of unreflective trust. There's no explicit mention, but it's visibly operating in the background. If you sort of understand the assumptions, why are we calling for an understanding of the properties of a cancer cell? You can understand that as under a mechanistic metaphysical framework. On the other hand, you have a sort of passionate affirmation. You have explicit arguments for a particular metaphysical framework. You have the idea that cancer is a process and we need to understand cancer as a process, and this is explicitly a part of what researchers are arguing for. But you can also have this question that I'm more interested in: are these the right attitudes? I think there are reasons to think they aren't the best attitudes in a way. And here are some reasons. These are sort of general to philosophy of science. These are not, my ideas, but I think in this context, they can be seen as supporting this idea. Namely, a sort of basic pessimistic meta-induction will tell us that our current scientific theories might turn out to be wrong. And a steadfast commitment to these metaphysical assumptions or to any particular theory maybe isn't the ultimate best thing for us to be doing. Another thing, metaphysical frameworks are underdetermined by available evidence. I'm not convinced that I'm going to know the ultimate answer to, what kinds of things there are in the universe, at least in my lifetime. We don't have that kind of evidence. We don't know. Is a mechanistic framework better? Is a process framework better? We're going to have metaphysical frameworks that are underdetermined by available evidence. And finally, when used to exclude avenues of research, choosing incorrectly comes with non-epistemic risks. So we can choose, it might seem like we're just, we're choosing wrong, and all that we're risking is being wrong. All that we're risking is false theories or false conclusions. But in the case of cancer, which is one of the reasons why I choose to talk about this, we have large non-epistemic risks, right? Deaths, it is one of the leading causes of death. So we have these concerns about health and well-being that can motivate us to want to get things right. I think that this is why ultimately we ought to have a pluralism. This is, again, I think is a thing that's sort of largely agreed upon. We should have a pluralism, and we're going to need a pluralism about the metaphysical presuppositions that are allowable in science, especially with the potential upset is a treatment or cure for one of the deadliest diseases in society. The thing I'm interested in is a methodological pluralism. But since, as I've sort of been saying, we can see that our methods are tied to our metaphysical presuppositions. Adopting a methodological pluralism requires that one has not prematurely restricted themselves to the use of a single type of metaphysical framework. And here's the key. Unfortunately, the sorts of attitudes that I was talking about, unreflective trust or passionate affirmation, they're both based on the idea that a single metaphysical framework is in fact the correct one. These attitudes are grounded in the idea that there is one correct metaphysical framework and we ought to understand everything in light of that framework. So they're not going to grant us the ability to use diverse methods. They're going to rule out methods from competing methodological frameworks. So should we just be agnostic? Should we just, we require that researchers remain agnostic to the ultimate truth of metaphysical frameworks and base methodological decisions on pragmatic aims only? I mean, an agnostic attitude towards metaphysical frameworks could help ground a sort of pluralism of research frameworks, but placing this metaphysical burden on individual researchers sort of misses the more systemic issues that cause certain research agendas to be pushed forward and others to be ignored. So if we focus on sort of the promotion of this overall agnostic attitude, I think we're not looking at the right sort of scale. We need to look to a sort of higher, a larger scale. And here I have some ideas. You know, this is the sketchiest part of this. I think the reasons we have for the adoption of methodological pluralism are really compelling. And I don't think that they're just compelling to philosophers. I think that they are compelling to general people who are invested in this project of curing cancer or finding solutions to the problems. So I think there are a variety of ways we can sort of use these arguments made at a higher level to try to create policy or create space for a genuine diversity of methodological approaches to research. Here are some things I have in mind by this. You can provide training on underdetermination of metaphysical frameworks by empirical research and inductive risk to gatekeepers in science, be those journal editors, grant reviewers, executives who are deciding on funding at big tech companies or big pharmaceutical companies doing a lot of this research. Perhaps trainings aren't the best thing. I'll say a little bit more about that in a second, but you could focus on creating policies that safeguard against the exclusive favoring of one sort of metaphysical framework at these higher levels. So you can institute review processes that mandate that we are open to a variety of different sort of approaches that are grounded in different metaphysical frameworks. But ultimately, here's the one that I think is most useful. We should look to the world of anti-bias training and look at the kinds of things that are successful and aren't successful in the world of anti-bias training, because really we can understand these sorts of metaphysical presuppositions to be forms of bias if we think about them this way. I think we can use that as a guide to figure out what would in fact be more successful, because at first I thought maybe training programs, but there's evidence that this doesn't work in the world of bias, so perhaps it would be mistaken to infer that it would work here. So that might be another helpful way for us to approach. But ultimately, I think what's most interesting to me is moving away from the level of the individual practitioner to these larger bodies that sort of guide the bigger ship of what happens in scientific practice. All right. I hope I didn't go over time. I'm not 100% sure when I started, but thank you.
Thank you. So we do have about six minutes for the questions. So please, if you have questions, again, at the bottom of the screen, you can find the icon participants. If you click on that, on the right, you should see raise hand function. So please use that if you have a question. So maybe I can start. I sort of really like the approach, but there is sort of a pushback. Let's say. So I do not understand exactly why would you say that the tissue organizational field theory is outside the mechanistic framework, So I don't see it as a sort of different metaphysics, and I don't see that there is this sort of discrepancy between the mechanistic framework and the processes. Of course, I know the literature somewhat, but yeah. So if you can say something.
Yeah. So I will admit, in a sense, I'm taking some people at their word. So I'm taking some literature, some people who are advocates of the tissue organizational field theory, or some people who are advocates of the process framework, and taking them at their word that this is a different, in fact, metaphysical framework. I think there are some superficial differences. I mean, assumptions if you don't take it to be a super deep word, if you don't take metaphysics to be fundamental, I'm not sure what that means, but if you just take it to be a sort of statement about what kinds of things there are, I think if you're these two assumptions about cells, so whether or not cells are by nature dynamic, whether or not by nature they are constantly changing, moving, varying, or by nature they are staying the same, you can see those as two sort of different metaphysical assumptions. I would say that that's probably, those are the two things I'm relying on to draw a contrast between these approaches to cancer specifically. I think the demand, so I think mechanism is really dominant, and it plays a huge role in, especially in